Well, hello everyone. Uh, the purpose of this video is to show you how you can expose your local services, local Kubernetes services running privately on your Raspberry Pi or on Minikube to the public internet with inlets-operator. Well, if you don't know about inlets-operator, it is a tool that allows you to expose your local services and get an external IP address, a static external IP address on a provider you choose. Uh, for this particular demo, I'm going to use GCE. Uh, for that, I have actually created a pull request to the official project, and that will basically allow us to provision the inlets exit node automatically on Google Compute Engine. Why Google Compute Engine? Well, because with every platform project, you can actually run an F1, the first F1 micro instance on a project for 700 hours for free every month. So that is basically 30 days. So for this particular demo, I'm actually going to follow along with the README that I have created for running Google Compute Engine. And purpose, we have to actually follow along with a few steps uh, that will actually allow us to create the service account credentials and the secrets necessary, and finally the deployment of inlets operator itself. So I'm going to just go through these commands one by one, and hopefully by the end of this demo, we actually have a static endpoint. Well, I have created a project ID environment variable holding the value of the project ID that we have already configured with gcloud. The next thing I'm going to do is to actually create a service account inlets that will be responsible for making the requests to the Google Compute Engine instance and the firewall rules that will allow us to basically have an exit node. So I see that the service account inlets already exists, and that is because previously I had run these commands. So what I'm going to do is I'm going to delete inlets service account, and yeah. So if I run this command again, okay, so the inlet service account is created. If I run gcloud im service accounts list, I have the inlet service account here. The next thing I want to do is to actually get the service account email into an environment variable. So there's that. The next thing I want to do is actually assign IAM roles to this particular service account, particularly the compute admin and the service account user roles. Compute admin role because I want to create instances on my project as well as create firewall rules required, particularly the inlets firewall rule, opening up the inlets port on our exit node so that uh, our local inlets client running locally on our cluster will be actually be able to get through that port. Uh, so for that, I'm going to run these two commands that will allow us to have access to compute and network resources. The next command is the assigning of the role of service account user. This will allow us to actually use this particular service account. The next thing I want to do is to create a service account JSON key file that will hold all of the credentials required for authenticating our requests to the Google Cloud API so that we can actually create the compute engine instance exit node as well as the firewall rules. So for that, I'm going to run gcloud IAM service account keys create. I'm outputting the contents into a key.json file, and there's a bunch of gibberish. So it contains the private key for authenticating our requests with this particular service account. Next thing we want to do is to actually create a Kubernetes secret out of this key file. So I'm going to run kubectl create generic inlets access key from file. The key here is important because the Helm chart actually depends on this particular key file name. Okay, so the secret is created. The next thing you want to do is to actually get the official Helm repo added to this to your local Helm chart. Uh, well, this pull request has not been merged yet. So what I'm going to do is actually go into the my project folder and then follow along with it. So I'm going to install inlets with Helm. So before that, I actually need to get into the chart directory and basically run this command. So I'm using the provider as GC. The zone is US Central 1A, and the project ID I'm getting from the project ID environment variable. So the inlets operator deployment is created. So the inlets operator pod is running. The next thing I want to do is actually get logs from this inlets operator pod. So for that, I'm going to switch panes and get logs from this instance. So on the right, you might be seeing on 1 and 3 panes, I'm listing out all of the compute engine instances on my project. Right now, I have none. And the firewall rules on my project in the default network. Um, so this will be useful to see how inlets operator is actually creating those instances and how fast it is on GCP. The next thing I want to do is to actually create a Nginx deployment, just like any deployment you create whether locally or on the cloud. So for that, I'm going to run kubectl run nginx image next port 80 and the restart policy as always on failure. So the nginx deployment is created. If I list out the parts, it is still creating. So the nginx deployment is running. So as with any cloud provider, whether it is GKE or EKS, when you expose a deployment, you get a network load balancer automatically created on your project. Well, we can do the same thing with inlets operator. So I'm just going to expose it like any other deployment. kubectl expose nginx. The port I want to use is 80 and the type will be load balancer. So if everything goes according to plan, as soon as I hit enter, operator will actually create, will actually check whether a firewall rule for inlets exists or not. And if it doesn't, it will create one. And then it will actually provision a exit node with the inlets network tag that will actually allow us to target the firewall rule to that particular instance. So I'm going to hit run. Uh, it says that the firewall rule does not exist. It has created a firewall rule here, and it provisioned the Google Compute Engine within 5 seconds. So that is crazy fast. If I run kubectl services, the status is still pending, and here we go. We have got an external IP for our Nginx deployment. So if you see my Google Compute Engine dashboard, you'll actually see that the Nginx kernel was automatically created for me. So this is really a great tool. Uh, it allows us to get static external IPs for something running on our. How crazy is that? So the next thing I want to do is actually ping this. So if I do a call, there, for the purpose of this demo, I'm going to hit it on my, yeah, there it is. Welcome to Nginx. Getting served from a machine running on my disk. And if you delete the service, inlets operator will take care of actually deleting the exit node too. So if I run kubectl delete svc nginx, it says it is deleting. And as you can see on the status here, the nginx external instance is stopping and soon will be deleted. If you like inlets operator, you can give it a try on just go to github.com/inlets/inlets operator and follow along. Thanks.